Let's do this problem from section 8.3. This is problem number 3. Sketch the region bounded by the curves and visually estimate the location of the centroid, then find the exact coordinates of the centroid. So the centroid is essentially the center of mass for an area. Instead of looking at individual masses discretely, by discrete I mean just dots, we're looking at an actual continuous areas, a continuous function that defines an area. And so we can have the moments and the total mass and the moments and the center of mass the same way we did this. The moments, again, where m sub y has an x in it, and so it's kind of like the same thing here. The moments about the y-axis will be something with an x in it. Now the moments about the x-axis has a y in it, but the y kind of got split up, and then we want this in terms of x because we're integrating in terms of x, and so the formula is going to look a little bit different, but it's essentially the same idea with the center of mass that we did before. Alright, so the region is symmetric about the y-axis, so if it's symmetric about the y-axis, we know that the x centroid, the x value for the centroid is going to be 0. And so that's going to save us some calculations. Visually, we should take a look at this, and we're assuming that rho is the densities even over the whole area. We would be looking at the centroid to be between 5 and 10, maybe a little bit closer to 5 than 10. So that's what we should be expecting in terms of trying to eyeball it. But we know for sure, because of the symmetry, that the x value of the centroid is going to be 0. Okay, now we want to find the area of the region. We can multiply this by 2, but it looks like they're going to go from -4 to +4. And then the actual parabola is just 16 minus x squared. So we're going to find the area of that and use that area as part of our integral to find the y component. So let's integrate this. It looks like we can double it up, so they end up doubling it up here. We're just going to go from 0 to 4 of this thing. The antiderivatives are going to be 16 minus x cubed divided by 3. And then we put 0 in there, it's going to disappear. So we put 4 in there. Let's see. We got 2 times 16 times 4 minus 4 cubed. 16 times 4 is 64 divided by 3. So let's see if we can work all this out. This is 64. We're gonna multiply it times 3 and then subtract. I think we're gonna get so 64 times 3 is 200 and something, but I think this is just gonna boil down to 128 over 3. And then we'll double this. That's 256 over 3, and I think we can't reduce that anymore, so oops, that was 256 over 3. So hopefully that's all good. Now our formula for the y bar is given down here. So the 1 over a is on the outside. We have 1/2. And then we have the function, which is 16 minus x squared. And then we're going to square that. So we're going to use symmetry again. Let's see how they use symmetry over here. So we have the a as 256 over 3, and the reciprocal of a, so that's 3 over 256. They took this 1/2 out. They changed the limits. Instead of going from -4 to 4, taking advantage of symmetry. they're going to double that and go from 0 to 4. And then they FOILed this for us. They multiplied it all out. And so now this is what we're concerned about. We want the antiderivative of this. So this is 256x minus, and now it's going to be 32 over 3 times x cubed. So it's x cubed over 3 plus x to the 5th over 5. Now comes the difficult part where we put 4 in. So this looks like it's going to be 2. Well, a lot of work. So let's see if we can do this. Why don't we just have our calculator do it for us? Let's call on I'm going to call on Wolfram Alpha to just do the computation for me. And what do we have? We have 3 divided by 256, and then the big parentheses over here we got 256 times 4. We're going to put 4 in, minus 32 divided by 3 times 4 to the 3rd power. This should be a minus here. And then we have 4 plus 4 to the 5th power, and we'll divide that by 5. Okay, so that looks like it's simplified to 32 over 5. And then so our point is going to be 0 and 32 over 5. Okay, so that's how we do that. The centroid, just remember our formulas. Our formulas for the center of mass for a continuous function or for an area is going to be 1 divided by area times 2 different integrals depending on whether you're looking for x bar or y bar. And also, if you see some symmetry in your problem, make sure you take advantage of that. So we had one less integral to do because the first component was 0. Okay, I hope that helps.